Okay, let's get these two done. So what you want to see is that I already put these in my calculator. So what I'm going to do is just graph them so you can already see the general shape. The first one is going to be in blue on my calculator, and the second one is in red on my calculator. So if you want to follow along, you can pause the video and type those in so you can practice. Let's go ahead and first of all, let's just talk about the end behavior of the blue one. So we'll take a look at the graph, and I can see that the blue one on the left is up and the blue one is down on the other side. So end behavior is down and up. Now, if you're looking for a general shape, the general shape looks something like that. Okay? Again, we're focused on the blue one. So I would like to talk to you about the turning points on this. So if we kind of like zoom in, it does appear as if it has a turning point. Maybe my drawing was a little bad. It does look like it comes down, pops a little bit back, pops a little bit back. So it does look like it has two turning points. So I'm going to write two turning points, not toilet paper, two turning points. So what's going to be kind of hard about this particular item is we need to find out what those turning points are, but not all of you have a TI calculator. So what you're going to do is you're going to hit this trace button, and we are on the blue line. We need to hit, we need to figure out, like, there's no other way to do this than kind of approximate. So we are going to move our line through until we see the Y value right there. It's going lower, 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 oop, lower, 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 lower. That's still lower, lower, right? Just kind of going through. Sorry, there's no other way. So I'm at negative 2.147, and now I move to negative 2.145. So I can see a turn is happening. So as I'm going through, like my black dot is going down, 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 down. And then it's going to start, see how it's hopping back up? That means that there was somewhere in here it took a turn. So I'm going to find that turn when my numbers start increasing. That happened right here. So approximately at x equals zero point 0.4. So my one turning point, I'm going to have to do approximations because now we would be using this feature, but we'd have to pay for that. So I just lost it. That's awesome. So I need to find the lowest it goes. I'm kind of trying to find the lowest it goes before it starts getting higher. There we go. It started getting higher. So I'm going to say approximately at 0.4, comma, negative 2.1. Okay, now these are approximate. If we had an actual TI calculator, we could find the real ones. So now what I'm going to do, just look at this blue dot. It's getting higher and higher and higher. So what I need to do is when it stops getting higher, once it starts getting lower, then I know that I'm reached a turning point. So it is getting higher there, higher there, higher there, higher, higher, higher. Wait, no, now it's coming down because we're in negatives. We are in negatives, so we are actually coming down. Okay, so that is higher than that one. Sorry, guys, there's no other way to do this with the free version of the calculator. So that's a little bit higher. That's a little bit higher. Okay, I'm going to go here. So at approximately 1.03, comma negative 2.0. So those are pretty approximate, but those are where the turns happen because I started seeing my y's increasing and then decreasing, or they were decreasing and now they're increasing. So those are the turning points. I'm sorry, guys. I know that's not like the easiest way to do it. So the blue line, let's take a look at our x-axis. This is how I always do it. So over here is negative infinity, over here is positive infinity, and my turning points happen, first of all, at 0.4. One of my turning points happen, and then I'm pulling that from here. And then another turning point happened at 1.03. So let's talk about what's happening. From negative infinity, oh, that was messy. From negative infinity to 0.4, I saw that it was going down. See how the line, like, the line goes like this. It goes, wow, and then it goes, wow. So it was going down. So I'm going to say that was decreasing. Now, from 0.4 to 1.03, it takes a little shot up right here. It takes a little shot up, so that's increasing. And then from here, it starts going down again, so it would be decreasing from 1.03 to positive infinity. Again, if I had a real TI-80 calculator that I knew everyone had, we could use exact numbers, but we're going to have to use approximations on these. Let's do part B. So y equals, that is going to be my red line. So my red line looks something like this. Boom, there you go. So if that's my red line, let's take a look at what's happening. First of all, I would like to say that the end behavior, pretty easy. End behavior we like. It's down and then up. End behavior is like, okay, I can handle that. And now for the turning points. The turning points, there's a potential. It looks like there's two. Because the power is a 3. Usually the number of turns is one smaller. So I'm going to do is I need to trace, but I need to hit the up arrow, so I'm on the red line. So I'm going to start over here. All right, now let's take a look at our y values. Ready? Increasing, 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 increasing. They're getting higher, 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 higher. Oh, if you guys looked, it never went down. So there's actually like in this little like turn here, there's actually not an actual turn because it continued to go up. That was weird. Let's keep going. Higher, 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 higher. See how the Y's are constantly getting higher? It doesn't turn. The reason it doesn't turn is because this one never like changes from going down to going up and up to down. This is always going up. Like it's always increasing as you go along that red line. So we can say from negative infinity to positive infinity, this thing's increasing, which is really nice. We don't have to do all that turning point stuff.